we're going to look at the first part of statistical inference, which is how do I take the results from my sample and generalize those to the population? So what we want is to be able to use the sample to draw conclusions about our entire population. So kind of picture-wise, the way that works is you start out with a giant group of people, your population. You're going to pull a representative sample from that population, and that sample you're going to get some data from, and you can calculate some statistics. So like in that first video for this chapter, we talked about they surveyed a certain number of American households and found that 18% of them had a computer. That 18% is a statistic. And so then what our goal is to use that 18% to be able to say, well, we think for the entire population, maybe 15 to 21% actually have a computer. So we're going to use that knowledge we get from the sample to make an estimated guess about our population. So if we have a random sample, that's the important thing we need is that random sample. That's what's going to give us our representative sample. That's what's going to allow us to generalize our results from the sample to the population. So anytime somebody asks, are you allowed to generalize your results? The thing that you're looking for is, do we have a random or representative sample? If the answer is yes, then you can apply your results to the population, generally speaking. Right? There's obviously some more nuances to it, but in general, that's the rule. Okay, if they did not pull a random sample, like you just asked 10 of your best friends, you cannot generalize those results to the population. All right, so the purpose of a sample is to give us information about a larger population. Inference is the process of drawing conclusions about a population from the sample data. So this is where we're getting that term statistical inference. We infer information about the population from what we know about the sample. So a couple of details here. We rely on random sampling to eliminate or minimize bias in selecting samples from the list of available individuals. We use random sampling because the laws of probability allow trustworthy inference about the population. We're going to look a little bit more at just very basic probability in Unit 4. But those laws of probability are what's going to allow us to make some of these predictions and good estimations about our population. Okay, and then the larger the random sample is, the more accurate your results are. And that should make some sense. And we'll actually look at why that's the case in Unit 5. There's some mathematics behind that. All right, so we have two examples that are in your notes. The first one is called Ask More People. In the 2012 pre-election surveys, Pew Research asked a sample of voters if they planned to vote for Obama. So about a month out, early October, they surveyed 1,100 people. A couple of weeks before, so this is the end of October, they surveyed about 1,500 voters. And then that week leading up to the elections, they surveyed 2,700. So quite a bit more than the first time around. Why did Pew keep increasing that sample size? Why didn't they keep the same sample size all the way through? All right, so pause the video and think about that for a second, and then we'll come back and talk about some possibilities. Okay, so there are a couple of different answers here. One of the easiest ones is just to refer to the last bullet point on the last slide, which is larger random samples give us more accurate results. And now if you look at the sample size and in relationship to when the election is, you'll notice that as they got closer and closer to the point where people have to make a decision to turn their ballot in, they're going to be more confident in what that decision is going to be. And so getting that larger group of voters right before the election is going to be able to help you really narrow those results down. So rather than saying, well, we think 40 to 80% of people are going to vote for this, you'll be able to narrow it down much more tightly and say, oh, it looks like 55 to 62% are going to vote for this. Okay. And then one more, how accurate is the poll? The New York Times, CBS News conducted a poll February 2014. One of the questions asked was, do you feel that the distribution of money and wealth in this country is fair? Or do you feel that the money and wealth in this country should be more evenly distributed among more people? So if we take these results and we look at the entire sample, so their entire sample was 1,644 adults. And so it looks like they have a pretty even split between Democrats, Republicans, Independents, and then there's 60 that just didn't identify with either group. And so those results had a margin of error of plus or minus 3%. So that means if the estimate was 60%, we would say that between 57 and 63%, that's at plus or minus 3, are going to vote for this. Now, if I surveyed only the Democrats, I would actually expect that to be much tighter because they would assume it just doesn't have to be Democrats, it could be the Republicans or Independents. I would think that if you're checking within one group, that those ideas and thoughts are going to be much more similar to each other as opposed to different when you're surveying a variety of political parties. However, the interesting thing is when they looked at just those 505 Democrats, they had a margin of error of plus or minus 6%. So if we stuck with that 60, that means instead of it just being 57 to 63, we'd be looking at 54 to 66%, which is a pretty wide range there. Okay. So the question is, why are the results less precise for the Democrats? I would have expected them to be more consistent since they're all from the same political party. So pause the video, take a second and think about that. All right, so my best guess here, well, one thing we know for sure, there's a larger group when we look at the entire sample, 1,600 versus the 505. I think maybe too that I might have had a faulty assumption in there. I assumed that maybe political parties were more homogenous on this idea, whether it's Dems or Republicans, and that might not be the case. And so even though I expected one political party, though the group was smaller, to maybe be more consistent in thought, that sample size really plays a big role in there. And so that larger the sample size is, the better you can narrow your results down.